what a functional groups. Fine. So now we have learnt that a hydrocarbon is made up of carbon and hydrogen. Let me take the simplest one, that is methane. Okay. So methane has a formula of CH4, isn't it? That means one single carbon is linked to four hydrogens, isn't it? So it is sharing its electron with four hydrogens to form a compound called as methane. Okay. Now we know that carbon is being linked to hydrogen. That means this hydrogen atom can be substituted by some other element. So, when I bring another element to substitute this hydrogen, this compound is no more a methane. Okay. So, instead, the element which has replaced this hydrogen will give it some new properties. Okay, children. So, when the element which is going to replace the hydrogen atom from a hydrocarbon, assigning them the new properties, then it is termed as functional group. So, what is a functional group? An heteroatom. What is a functional group? An heteroatom, which will assign new properties, okay, to whom? To that particular hydrocarbon. So why? Because no more the as you all know, a particular element will have certain specific properties. So that atom, whichever is going to bond with carbon by replacing hydrogen, will give that its own properties to this particular hydrocarbon. So that is why they are called as what? A functional group. Okay, so now there are various types of functional groups. Right now in your 10th standard, we'll be talking about the 5 main types of functional group. Now, as I told children, how is this what is this heteroatom doing? It is replacing this hydrogen atom. Now, generally what happens when any hydrocarbon is less of one hydrogen, that is, now here if you see in methane there are how many hydrogens? 4. But if I remove one hydrogen, that means what would be my formula now? CH3. Then this compound is called as an alkyl hydrocarbon. So what is an alkyl hydrocarbon? Any hydrocarbon which is having one hydrogen less. Okay, one hydrogen less. That is, if I put the general formula, it goes like this: CnH2n plus 1. Okay, so when one hydrogen atom is less, then it is termed as what? Alkyl. Now what happened to this hydrogen atom? This hydrogen atom which has been removed must have been substituted with another atom, or must have got bonded with another chain of hydrocarbons. So if I take up methane, when it has lost one hydrogen, it would be named with a prefix as "-il". So that means methane becomes methyl. Similarly, if I take up ethane, C2H6. Okay, so then what will happen? If it loses one hydrogen, it would be C2H5. So where C2H6 is termed as ethane, this would be termed as ethyl. Similarly, propyl, butyl. Okay, children. So, by replacing that one hydrogen in an alkyl group, the heteroatom will assign specific properties, and these are only called as what? A functional group. So now let us continue with the various types of functional groups. So now let us start, children. So now the first functional group which we are going to talk about is halogen. I hope you can remember this name. So what are halogens? To which group do they belong? Yes, very good. If you can recall, that is the 7th group elements in the periodic table, which are called as what? Halogens, because they form the salts, isn't it? So can you remember the names of some of these halogens? Yes, it starts with what? That is fluorine, chlorine, bromine, and iodine. Now, very commonly the elements which we talk about in halogens is your chlorine, bromine and iodine. Okay. So now these halogens will react with, we can say will substitute the hydrogen in the alkane group in order to form the new compounds, isn't it? So now what would be the general formula of this halogen? It would be R. Let me take with an example of water, Cl. So I will mention it as water, RCl. Okay. So, and how do I read? Now, whenever we are naming these functional groups, either we will have a prefix or a suffix. Okay, children. Now here, in case of halogens, the functional group will be named with a prefix. Okay, so that means we will read the halogen name first, followed by the alkyl group. Okay, children. Now, where this R is representing water and alkyl group. So, if I have to read the name, it will go as chloro, bromo, iodo. Okay, children. So, let us just understand this in a better manner with an example. So, let us take the simplest alkane. What is that? Methane. Okay. So, what is the formula of methane? CH4. Now, so when a halogen has to link or bond with an alkane group, what it is going to do, as we have told, it will replace one hydrogen. So that means, so if I write the open structure, it goes like this. So 1C. Now, so what will happen now? Now, out of this 4 hydrogens, one hydrogen will be replaced by, let us take one halogen element, that is chlorine. So now the hydrogen got replaced with chlorine. So now what would be the formula? Will it be CH4 anymore? No, it becomes as CH3Cl. Okay, children. Now, what would be its IUPAC name? It would be with the prefix of the halogen followed by the alkyl group. So, what is my prefix here? The prefix here is chloro. What is the prefix? Chloro. And what is the alkyl group? Meth. So, chloromethane. So, what is the IUPAC name of this compound? Chloromethane. But commonly, if you have to talk about the common name, it can be named as methyl chloride. So you see, when we follow the IUPAC name, it is the prefix of the functional group. But when we are talking about the common name, it would be a suffix. So methyl chloride. But IUPAC name is what? Chloromethane. Okay, children. So now let us take one more example. That is another alkane. The next simplest alkane, that is ethane. So as usual, as I told, one hydrogen would be replaced. Okay. So if I write the open structure, C, yeah. So this is my actual bonding of the ethane compound. So let me put. Now, how many hydrogens would be replaced? One hydrogen. So that means I'm linking to this carbon. It can be to anyone. Okay. So about that we will talk in the nomenclature as we proceed further. So let me put over here. So now what would be the formula? How many carbons, children? 2. Then how many hydrogens? 5. So C2H5Cl. So what would be its name? Chloroethane. Okay, chloroethane. Clear, children? And common name would be ethyl chloride. Similarly, coming to another one, that is methane, C3H8. I hope this you can try at home. Okay, children? So this was about water, the first functional group, that is halogen. Now let us discuss about the next functional group, that is called as alcohol. What is the next functional group? Alcohol. Okay. Now, this alcohol, the formula is ROH. Okay. What is the formula? ROH. And where R is, of course, the alkyl group. And the name of this alcohol group will be ending with the suffix called as ol. What would be the ending name of the functional group? Ol. So any alkyl group which will have an alcohol compound will be ending with the name as ol. So let us take an example and then we can understand. So again start with the simplest one, that is methane. So as usual, replacing one hydrogen. So how many hydrogens actually in a methane group? 4. So only we will mention now here how many? 3. And what about the another hydrogen got replaced with this alcohol group? And what is the formula? OH. Okay. So now the formula becomes as CH3OH. Okay, children. Now, how will I read the name? As I told, it will be ending with what? Ol. So, read the root name first. So, what is the root name? Meth. So, actually it is methane. So, since alcohol as substitute is being substituted in a methane group, in a methyl group, we read it as methanol. So, what would be its name? IUPAC name? Methanol. Okay, children. Similarly, let us see for ethane. So ethane, again same, substituting one hydrogen atom. So let me substitute here. So OH, and rest all are what? Hydrogen atoms, isn't it? So now what would be the formula? Ce2H5, yes, OH. And what would be its name? IUPAC name? Ethanol. Okay, ethanol. Or commonly we can read this as methyl alcohol. Ethyl alcohol. But IUPAC goes as methanol. Ethanol. Okay, children. So I hope now you can now construct the structures of the alcohol of propane and butane. Okay. So take these two as your homework. So now let us move to the next functional group.